Welcome to the Sleepy Scholar. It's lovely to have you here tonight, wherever you happen to be. Maybe you're tucked under a heavy blanket with just the corner of a lamp still glowing. Maybe you're lying flat in the dark, eyes already halfway closed, listening to the sound of a voice more than the shape of the words. Maybe you're on a train, or a couch, or a bed that isn't your own. Wherever you are in the world, whatever hour has crept up on your corner of it, I'm glad you found your way here. So let me ask you, before we begin, where in the world are you listening from tonight? Leave it in a comment if you feel like it, and tell me what the hour is where you are. It's a small thing, but it makes this quiet room feel a little less empty. And while I'm asking small things of you, let me ask one more. If these slow journeys help you drift off, a gentle like and a subscribe really do help this sleepy little channel keep going. Small creators like me lean on that more than you'd think. To those of you already subscribed, already returning, already making this a nightly ritual, thank you. Truly, you don't have to do anything at all, of course. You can simply lie there and let the words wash over you. That's the whole point. Because here's the deal we're making tonight, you and I. I'm going to walk you very slowly through one strange and beautiful thing floating out in the dark, and you are allowed to fall asleep at any point along the way. There's no test. There's no moment you have to be awake for. If you drift off before we reach the end, that's perfectly fine. The object we're talking about has been sitting out there, patient and unbothered, for far longer than either of us can imagine. It'll still be there in the morning. It'll still be there long after that. So there's no rush. None at all. We'll take this one soft step at a time, and I'll try, as always, not to make it so interesting that it keeps you awake. Though if it does, well, at least you'll have learnt something lovely. A fair trade. So settle in. Let your shoulders drop away from your ears. Let the day you had start to loosen its grip. And let me tell you about a ring in the sky. I want you to picture something. Not a diagram, not a photograph, just a shape held gently in your mind. Picture a ring. A perfect glowing ring hanging in the blackness. Not a thin wire of a thing, not a delicate halo, but a thick, luminous circle, blazing with the light of young stars. And these are not ordinary stars, not the calm yellow ones you might imagine. These are hot, furious, brilliant blue stars, the kind that burn hard and fast, the kind that flare into being and blaze so intensely that their light tips over into blue. Astronomers call these O and B stars, the hottest and brightest classes there are, and they don't live long. A star like that shines for only a few million years, which in the life of the universe is barely a breath. So a ring full of them is a ring that is making new stars right now, or as near to now as makes no difference. Scattered all along that ring are glowing pockets of gas, clouds where fresh stars are still being born, regions astronomers call high regions, which is just a name for great clouds of hydrogen lit up and set aglow by the newborn stars inside them. The whole ring, then, is a nursery, a vast, circular nursery of the brightest, bluest, youngest stars. Now hold that ring in your mind, and let me tell you how big it is. Because this is where it stops being a pretty shape and starts being something that presses on you a little, something that makes you go quiet. That ring is about 120,000 light-years across. Let me sit with that number for a moment, because a number like that slides right past you if you're not careful. A light-year is the distance light travels in a year, and light is the fastest thing there is, moving so quickly it could circle the entire Earth 7.5 times in a single second. Now imagine that impossible speed, that light. setting out from one edge of this ring and racing straight across to the other side. It would take 120,000 years to get there. 120,000 years, just to cross from one rim to the other. The whole span of human history. All of it. Every empire and every song and every person who ever lived. All of that has unfolded in a fraction of the time it would take a beam of light to travel across this single ring of stars. And here's the part that ought to make you catch your breath, softly, gently. Not enough to wake you, just enough to feel it. Our own galaxy, the Milky Way, the great disk of hundreds of billions of stars that holds our sun and our little Earth and everyone you have ever known. That whole galaxy is about 100,000 light-years across, which means this ring, this single glowing circle of blue stars, is wider than our entire galaxy. If you could somehow take the Milky Way, take the whole of it, the spiral arms, the crowded core, all of it, and set it down inside this ring, our galaxy would fit within the circle with room to spare. The sun would sit somewhere in the band of the ring itself. This is not a delicate thing. This is not jewelry hanging in the sky. This is a galaxy's worth of stars, bent into the shape of a circle. Take a slow breath, let that settle. And now, in the very center of this enormous ring, picture something completely different. Not blue, not young, not furious. In the middle, floating alone, there is a ball, a rounded golden ball of stars, warm and calm and old. Where the ring is all hot blue youth, the core is the opposite in every way. These are ancient stars, cooler stars, the ones that have long since settled into a slow, steady yellow and red glow. Old suns, quietly burning down. There's no wild star-making going on in there, no bright new nurseries. It's a population astronomers sometimes call, a little bluntly, red and dead. Not dead in any frightening way, just finished with the business of making anything new. Old and calm and gold. This golden core is smaller than the ring, of course, though still enormous by any measure you or I could feel. It stretches somewhere between 17,000 and 24,000 light-years across, depending on exactly where you decide its fuzzy edge lies. Which is to say, the core alone is still the size of a good chunk of a galaxy. But set against that 120,000 light-year ring, it looks compact. A tidy golden ball at the heart of a vast blue circle. And between the two, between the old golden core in the middle and the young blue ring around the outside, there is a gap. This is the strangest part of all, I think. Between the core and the ring, there is a wide, dark, near-empty space. Tens of thousands of light-years of it, not entirely empty, nothing in space ever quite is, but startlingly, conspicuously low on bright material. There's very little luminous stuff bridging the two. The old golden ball sits alone in the middle. The young blue ring floats far out around the edge, and in between them, a clean, dark moat. It's this gap that gives the whole object its almost impossible, almost geometric look. An old core, a young ring, and a near-perfect emptiness holding them apart, like something drawn with a compass rather than grown by the messy hand of nature. So that's the picture. Hold it there, gently, in the dark behind your eyes. A ball of ancient golden stars, a ring of brilliant young blue stars, wider than our whole galaxy, and a clean, dark gap between them, tidy and round and strange. This is Hoag's object, and tonight we're going to try to understand it. Now, I have to be honest with you right at the start, because honesty is part of the calm here. I'm not going to be able to give you a tidy answer at the end of this. I'm not going to arrive at some final, satisfying solution, because there isn't one. Nobody has one. This object has been sitting out there in plain sight, catalogued and photographed and studied for more than 70 years, and in all that time, with all our telescopes and all our clever astronomers, no one has been able to fully explain how it came to be. That's not me building up suspense. That's just the truth of it. It is one of the cleanest, unsolved puzzles in all of astronomy, and part of what we're going to do tonight is understand exactly why it's so hard to explain. Not just to shrug and say nobody knows, but to actually walk through what the best explanations are and to see with our own minds exactly where each one falls apart. But that's for later. That's for the slow middle of the night. For now, let's just get to know the object itself and the man who first noticed it. Let me take you back then, back to 1950. Picture an astronomer at that time, in the middle of the last century, before we had any of the great instruments we lean on now. No Hubble Space Telescope floating serenely above the atmosphere. No digital sensors. Just glass and mirrors and photographic plates and a great deal of patience in cold rooms under dark skies. And there was an American astronomer named Arthur Allen Hoag going about his work, looking, as astronomers do, at the peculiar odds and ends of the sky, the things that don't fit neatly into the tidy categories. And in 1950, he came across something he could not quite make sense of. A round core, and around it, detached. A ring. He published it that same year, in 1950, as a probable example of a strange new kind of object that astronomers were only just beginning to appreciate. And ever since, the thing has carried his name. Hoag's object. It lives in a part of the sky belonging to the constellation Serpens Caput. That name is worth a slow moment because it's a lovely one. Serpens is the serpent, and caput means the head. Serpens Caput, then, is the head of the serpent. It sits in the northern half of the sky. But don't imagine for a second that you could step outside tonight, wherever you are, and look up and find this thing with your own eyes. You couldn't. It is far, far too faint. The core glows at around 16th magnitude, which is astronomers' language for very dim indeed. Dim enough that it takes a serious telescope even to catch it, let alone to see it as anything more than a faint smudge. It hides in the head of the serpent, invisible to us, and it hid there in plain sight until Arthur Hoag came along and noticed the smudge that wasn't quite like the others. And here is the thing I love most about the story of its discovery. The thing I want you to carry with you into sleep tonight, because it's such a wonderfully human moment. When Arthur Hoag first looked at this object, his first thought was that it might not be real. Not real, I mean in the sense of not being an actual ring. He wondered whether he might be looking at a trick, an illusion, because there is a phenomenon in the universe, a genuine and beautiful one, where the light from a distant object gets bent and warped on its long journey to us. Gravity, it turns out, doesn't just pull on things you can touch, it bends the very path that light travels through, and if there's something very massive sitting directly between us and some far more distant source of light, that mass can act like a lens, a great invisible lens made of gravity, bending and smearing the distant light as it passes by. And if the alignment is just right, just perfectly, symmetrically right, the light from that distant object can get smeared all the way around into a ring. A complete circle of warped light with the lensing mass sitting in the middle. Astronomers call this an Einstein ring, after Albert Einstein, whose theory of gravity predicted that light would bend this way in the first place. The whole effect is called gravitational lensing, and it is real. It genuinely happens out there. We've seen it many times since. So it was a perfectly reasonable thing for Arthur Hoag to wonder. He looked at this ring, this impossibly clean ring around a central ball, and he thought, quite sensibly, maybe I'm not looking at a real ring of stars at all. Maybe I'm looking at the light of some distant thing, bent by the gravity of a nearer thing, smeared into a circle. A mirage, an illusion of geometry, painted by gravity across the dark. Isn't that a wonderful thing, though? The man who discovered it doubted his own eyes. He looked at the most striking object he'd ever come across, and his first instinct was caution, was skepticism, was, maybe this isn't what it looks like. That's science at its most honest and its most human. Not leaping to wonder, but pausing to ask, could I be fooling myself? Now, I'll tell you plainly that his doubt turned out to be unfounded. The ring is real. It is a genuine ring of actual stars, not a smeared illusion of some distant light. And there's a very specific, very elegant reason we know that for certain, a single clean fact that put the illusion idea to rest. But I'm not going to tell you what it is just yet. I want us to come back to it later, once we've travelled a little further, because it's the kind of fact that lands better when you've been sitting with the question for a while. So hold on to that. Tuck it in the back of your mind. The discoverer thought it might be an illusion. Something proved him wrong. We'll get there. And there's one more thing I want to plant in your mind before we drift onward. One more small strangeness, and then I'll let the pace slow right down again. If you were to look very closely at this object, if you had the finest image ever taken of it, and you let your eye travel across that clean dark gap between the golden core and the blue ring, you would notice something tucked in there, something small. Off to one side, in the gap, roughly at the position you might call 1 o'clock, if the whole thing were a clock face, there is another ring. A second, smaller ring galaxy, glimpsed through the gap of the first. A ring, seen through a ring. Now your mind will want to leap to all sorts of conclusions about that, and I understand the temptation completely. It looks, at first glance, like it must mean something, like these two rings must be connected, companions, partners circling one another in some grand cosmic dance. But it is not what it seems, and what it actually is in some ways even stranger and more wonderful than a partnership would be. That, too, is a thread we'll pull on later tonight, once we've earned it. For now, just hold the image. A great ring in the sky, and through the gap in its middle, a second smaller ring, waiting, but here's where we should slow down, because I can feel us picking up speed, and that's not what tonight is for. Let me just let you sit for a moment with how rare this thing is. Because it would be easy to assume, given how many galaxies there are out in the universe. More galaxies than there are grains of sand on all the beaches of the earth, that a ring like this must be reasonably common. Surely, you'd think, with that many galaxies, plenty of them would end up as rings. But no, that's not how it works at all. The overwhelming majority of galaxies are the familiar kinds. Great spirals, like our own Milky Way, with their sweeping arms wound around a bright centre. Or ellipticals, smooth, featureless balls of old stars, or the smaller, fainter, irregular ones, with no clear shape at all. Rings are rare, and a ring like Hoag's object, a clean, detached, symmetric ring floating around a compact core with almost nothing in between, is rarer still. Vanishingly rare. The kind of object that is so uncommon it gives its name to its own entire category. Astronomers speak of Hoag-type galaxies, and when they do, they mean the small handful of objects that resemble this one. And of that small handful, Hoag's object itself remains the finest example, the most symmetric, the most striking, the prototype against which all the others are measured. It is the original, the one that started the whole conversation. So that is where we find ourselves tonight, sitting quietly with an object that is genuinely one of a kind. A ring of young blue stars, wider than our entire galaxy, encircling a ball of ancient golden ones, with a clean, dark gap between them. Discovered by a careful man named Allen Hoag in 1950, hidden in the head of the serpent, too faint for any human eye to catch unaided. So strange that its own discoverer wondered whether it was even real. And through the gap in its middle, by some quiet coincidence we haven't yet unwrapped, a second ring. Waiting, let your breathing slow. There's nowhere to be, nothing to solve tonight, not really. We're just going to keep drifting, slowly, softly, one mystery at a time, out toward that ring hanging silent in the dark. And before we drift on to the question of how far away it truly is, and what that distance really means, I want you to do one gentle thing for me. I want you to notice how you're already imagining it. That ring, that golden ball at its heart. Whatever picture your mind has built, hold it lightly, because part of what we're going to discover together as the night goes on is that Hoag's object has a way of not being quite what it first appears. It looks perfect. It looks designed, almost, as though some careful hand drew it with a compass and a steady wrist. And that appearance of perfection is one of the most interesting things about it. Because, as we'll see, the perfection is partly a trick of where we happen to be standing, and partly a trick of not looking closely enough. The universe didn't set out to make something perfect. It made something that, from our particular vantage point, hundreds of millions of light years away, and looking at just the right angle, happens to look almost perfect. And that's a subtler, and I think a lovelier, kind of truth. But that's ahead of us. For now, let's just stay here, in the quiet, with the ring and the core and the gap. I said the whole object is faint. 16th magnitude for the core, far below what any eye could see. And you might reasonably wonder why something so enormous, a ring wider than an entire galaxy, would be so dim that we can barely catch it even with good instruments. And the answer to that is bound up in the next thing I want to tell you, which is the matter of distance. Because the reason this galaxy-sized object appears to us as nothing more than a faint smudge, the reason it stayed hidden in the head of the serpent until 1950, is that it is a very, very long way away. Further than you're probably imagining, even now, even having heard how big it is. And distance, out in the universe, is a strange and beautiful thing, because distance is also time. To look far out into space is to look far back into the past. The further away a thing is, the longer its light has been travelling to reach us, and so the older the news it carries. When we finally get to the true distance of Hoag's object, and I promise you we will, slowly, in a little while, you're going to find that we are not even seeing this ring as it is. We're seeing a message it sent an almost unthinkable time ago. What it looks like now, tonight, in this very moment, is something we cannot know, and won't know, for longer than our whole species has existed. But we'll come to that gently. For now, just rest. You've done the hard part already, which was letting the day go and letting yourself arrive here, in the quiet, with a strange ring in the sky and a voice to keep you company. Keep that picture soft in your mind. The blue ring, so wide that light takes 120,000 years just to cross it. The golden core, old and calm, floating at its heart. The clean, dark gap between them. Tens of thousands of light years of near emptiness. Arthur Hoag in 1950, squinting at a smudge in the head of the serpent, wondering if his own eyes were playing a trick on him. And through the gap, that second small ring, patient, waiting for us to understand what it really is. We've a long, slow way still to travel tonight, out across those hundreds of millions of light years, into the question of how such a thing could ever have come to be. There are two great explanations for it, you'll find, two competing stories astronomers have argued over for decades, and each of them has a fatal flaw hiding inside it. We'll lay them side by side when we get there, and we'll see exactly where each one breaks. But not yet. Not for a long while yet. For now, there's only the ring and the dark, and your slow, easy breathing, and the enormous quiet patience of a thing that has hung out there, unbothered and unexplained, for far longer than anyone has been alive to wonder about it. So let's keep drifting, slowly, softly, out toward the true scale of the thing, and the strange, deep distance that separates us from that silent, glowing ring. Let me linger on that distance for a moment, because it's easy to say the words 600 million light years and let them slide past you like any other big number. But sit with it. When you look at Hoag's object, you are not looking at something far away in space alone. You are looking at something far away in time. The light landing on the mirror of the telescope tonight left that ring around 600 million years ago. It set out across the dark, before there were flowers on the earth, before there were trees, back when the most complicated living things on our whole planet were soft, strange creatures drifting in ancient seas. That light has been travelling the entire time, falling through the black, crossing empty stretches so vast they have no real edges. And only now, tonight, at the very end of that impossibly long journey, does it finally arrive, just in time to be gathered up and turned into a picture for us to wonder at. We are not seeing the ring as it is. We are seeing a very old letter, still in the post. And before we drift any deeper into it, let me just say a quiet thank you for being here. If you find these slow nights helpful, a gentle like and a subscribe really do help this sleepy little channel keep going. I'm a small creator, and honestly, that small tap is what lets me keep making these. So, if you've got the energy to spare before sleep takes you, I'd be grateful. And to those of you already subscribed, already here, already part of this quiet little ritual, thank you. Truly, before you close your eyes, I'd love to know, in a soft, idle way, where in the world you're listening from tonight, and what time it is in your corner of the dark. Somewhere it's late and raining. Somewhere it's the middle of a long afternoon. It's a nice thing to think about, all of us scattered across the planet, drifting toward the same strange ring in the sky. Now, there's no need to hold on to any of this. That's the promise I make you every night, and I'll make it again. You don't have to concentrate. You don't have to remember the numbers, or the names, or which star is old and which is young. If you drift off before we reach the end, that's not a failure, that's the whole point. The ideas will still be here. The ring will still be there, 600 million light years away, exactly as unbothered as it was before you fell asleep. I'll keep talking, slowly, softly, and you can simply let the words become a kind of warm weather in the room. We're in no hurry at all. We have the whole night. So let's go back to the beginning of this story, to the man who first saw it. The year is 1950. An American astronomer named Arthur Allen Hoag is looking, carefully, at the sky in the constellation Serpens Caput, the head of the serpent. It's a faint patch of the northern heavens, nothing you'd ever pick out with your naked eye. And this particular object is far too dim to see without a proper telescope, hovering down around 16th magnitude, which is really just a way of saying faint, faint, faint. And there, in the images, Hoag finds something that doesn't quite make sense. A round core. And around it, separated by a dark gap, a ring. A near-perfect ring of light, floating with nothing obvious holding it up. Now, here's the thing I love about this moment, and it's the first little knot in our story tonight. Hoag did not immediately believe it was real. Think about that. The man who discovered it, the man whose name it now carries, looked at his own picture and wondered if his eyes, or rather his telescope, were fooling him. Because the sky can play tricks. And Hoag knew of a particular kind of trick that might explain a ring like this without there being any real ring at all. The trick has to do with gravity, and with light, and with the strange fact that heavy things in space can bend the path of light passing near them. Imagine you've got a lamp far away, a single small source of light. And imagine that, sitting exactly between you and that lamp, there's something very massive. A dense clump of matter. A whole galaxy's worth. That mass warps the space around it, and light from the lamp behind it, instead of coming straight to you, gets bent as it goes by, smeared and curved around the massive thing in the middle. And if everything lines up just right, dead center, that far-off point of light doesn't reach you as a point at all. It reaches you as a ring, a perfect circle of light wrapped around the object, doing the bending. Astronomers call that an Einstein ring, and the whole effect is called gravitational lensing. Space itself acting like a lens. So you can see why Hoag paused. What if his ring wasn't a real structure? What if he was simply looking at some ordinary, far-off blob of light, unlucky enough to sit directly behind a heavy foreground core, its glow bent and stretched into a false circle by gravity? That would be a beautiful illusion, but only an illusion. A mirage in the sky. It would mean the ring and the core had nothing to do with each other, that they only appeared joined because they happened to line up along the same thread of our vision. It was a completely reasonable thing to wonder in 1950. And for a while, the question hung there, unanswered. We'll come back to how that doubt was finally put to rest. Because the answer is quietly one of the most important facts in this whole story, and it's what lets us say, with confidence, that the ring is real, that it truly belongs to the core, that the two of them are bound together as one single thing. But I want to leave that hanging just a little longer, the way Hoag had to leave it hanging. A good doubt deserves to be sat with. Because here's where it gets stranger still. If you look very closely at that dark gap between the core and the ring, at the empty space where there should be almost nothing at all, you'll find that it isn't quite empty. There, tucked into the gap, off toward one edge, is another ring. A second, smaller ring galaxy glimpsed straight through the hole in the first. A ring seen through a ring. And your first thought, quite naturally, is that they must be companions, two ringed things keeping each other company out there in the dark. But that, my sleepy friend, is another trick of the line of sight, and not at all what it seems. But we will get to that second ring in good time. Let's hold it there for now, a small glowing mystery parked in the gap, and first do something that I think matters more than almost anything else in this whole quiet journey. Let's work out where we actually are. because the ring looked small in Hoag's original photograph. It looked like a lot of things in the sky look, distant, faint, reduced by the sheer cruelty of space into something your eye could cover with a fingertip. And there is a way of looking at that photograph and feeling almost nothing, the way you might feel nothing looking at a grain of sand on a beach, because your brain hasn't been given the numbers yet. So let's give it the numbers. Let's really go there. Hoag's object is not nearby. Nothing in this story is nearby. It sits in the direction of Serpens Caput, the head of the serpent, which is a modest northern constellation that most people have never spent much time thinking about, a scattering of middling stars. Nothing dramatic on the surface. But that's where the light is coming from. When you point a telescope into that region of the sky and tune your instruments carefully, Hoag's object glimmers back at around 16th magnitude. That is extremely faint. The faintest star most people can see on a very dark night with very good eyes is around 6th magnitude. Hoag's object is 10 full steps fainter than that in astronomical terms, which corresponds to a factor of 10,000 times less light reaching your eye. You could stare at exactly that spot in the sky for the rest of your life and never see it. It is an object that requires patience, equipment, and darkness, and still rewards you with something you have to squint at. And the reason it is so faint is partly the reason the numbers are about to feel very large. When astronomers look at a distant object, one of the first things they measure is its redshift. You may have encountered this word before, perhaps in other late-night wanderings through the universe. The basic idea is gentle and worth dwelling on for just a moment. Light travels at a fixed speed, but the universe is not fixed, it's expanding. Galaxies are not rushing away from us through space in the way a car rushes away down a road. It's subtler than that. The space between us and them is itself growing, stretching, like the surface of a slowly inflating balloon. And as that space stretches, it also stretches the light travelling across it. Light that started out as a particular shade of blue arrives after a very long journey. Shifted toward the red end of the spectrum, the further the object, the more the space between us has stretched during the light's journey, and the more the light is shifted toward red. This is the redshift, and it is one of the most powerful tools astronomers have. Hoag's object has a redshift of approximately 0.0432. That's written as z equals 0.0432 if you are in the habit of thinking in those terms, though there is no need to hold the number in mind. What matters is what it translates to. A redshift of that size corresponds to a recession velocity, the speed at which the object is being carried away from us by the expansion of space, of roughly 12,740 kilometers per second. Pause on that for a moment. 12,740 kilometers. Every second. Not every hour. Every second. Light itself travels at about 300,000 kilometers per second, so we're talking about something receding at roughly 4% of the speed of light. And yet, cosmically speaking, this is not considered especially fast. This is the middle distance. A comfortable stroll by the standards of the observable universe. Translate that recession velocity into an actual distance, using the standard relationship between redshift and distance that astronomers have refined for decades now, and you get something in the neighborhood of 600 million light-years. Some estimates say 610, some say a little under 600. The precise figure shifts slightly depending on which value you use for the Hubble constant, which is itself a number astronomers have been arguing about with great affection and considerable frustration for a long time. but roughly 600 million light-years is where the best current understanding places it. Let's say 600, because round numbers carry their own kind of dignity when the numbers are this large. 600 million light-years. 1 light-year is the distance light travels in a year, which is about 9.5 trillion kilometers. So 600 million light-years is 600 million multiplied by 9.5 trillion kilometers. I am not going to ask you to actually compute that, because no human brain holds such a number in any meaningful way. What I'd rather you do is try a different approach. Try to feel it. Close your eyes if you like, or keep them open. This works either way. Imagine stepping outside tonight, or maybe you're already in bed, the window dark beside you. The light that reaches your eyes from a nearby street lamp left that lamp perhaps a few millionths of a second ago. The moonlight you might have seen this evening left the moon about 1.25 seconds ago. Sunlight, if you caught any today, left the sun about 8 minutes ago. The light from the nearest star beyond our sun, Proxima Centauri, takes just over 4 years. Andromeda, our nearest large galactic neighbour, 2.5 million years. The light we receive from Hoag's object left it 600 million years ago. 600 million years, that is not an abstraction, that is a specific, real historical time. 600 million years ago, on Earth, was the very end of something called the Ediacaran period and the very opening of the Cambrian, the time when complex multicellular life was just beginning to diversify, slowly, experimentally, into the forms that would eventually produce everything that has ever moved across this planet. No fish yet, no insects, no trees, no flowers, no birds, nothing you would recognize walking on land. The oceans were full of soft, strange, quilted creatures, things without bones or eyes or mouths in any recognizable shape, drifting in shallow Ediacaran seas. And at that exact moment, as those first complex animals were feeling their way toward existence on one small planet, the light that will one day reach Arthur Hoag's photographic plate in 1950 left a ring galaxy 600 million light-years away. That light has been traveling for longer than complex animal life has existed on Earth. It has been traveling since before there were eyes to receive light at all. And this means something quietly extraordinary. We do not know what Hoag's object looks like now. We cannot. The image we have, the beautiful Hubble image, the photographs, everything, shows us the galaxy as it was 600 million years ago. Whatever is happening there at this moment, in whatever year this moment would be labelled at that distance, we will not find out for another 600 million years. The universe keeps its secrets in the most literal possible way by making the speed of light the absolute ceiling on information transfer, and then being very, very large. So when you look at Hoag's object, you are looking backward, always backward. It is a kind of time travel that requires no machinery, only a telescope and the patience to remember what you're actually seeing. Now, let's look at what we're actually seeing and why it is so strange. The outer ring, the blue glowing arc that gives the object its iconic look, is approximately 120,000 light-years in diameter. 120,000 light-years. For comparison, our own galaxy, the Milky Way, has a stellar disk of roughly 100,000 light-years across. The ring of Hoag's object is wider than the entire Milky Way. Not bigger than a dwarf galaxy's little halo, not bigger than some faint peripheral structure. Wider than the whole disk, the whole sweeping arm-laden pancake of stars in which our Sun and its 8 planets and all the history of Earth is embedded. That ring could contain our galaxy with room to spare. And the ring is not solid, not featureless. It is made of stars, and specifically of young ones. Very young, in stellar terms. The ring is dominated by what astronomers call O stars and B stars, the hottest, most luminous, shortest-lived class of stars in the known universe. O and B stars burn so fiercely that they exhaust their fuel in a few million years at most. Some of the most extreme ones last only a few 100,000 years before they explode. On a cosmic timescale, this is nothing. It is a mayfly's afternoon. And the fact that O and B stars are present in the ring, glowing blue and ultraviolet and fierce, means that they must have formed very recently, in cosmological terms at least. They couldn't have formed long ago and still be here. They are new. Woven among them are what are called high regions, pockets of ionized hydrogen gas. Clouds lit from within by the intense radiation of the young stars nearby. High regions are among the clearest signs of active star formation anywhere in the universe. They glow pink and red in certain wavelengths, though what you mostly notice in a visible light image is the blue dominance of the O and B stars themselves. The ring is alive in a sense. Or at least it was alive 600 million years ago when the light left. Something is building stars out there. Now step inward. Cross that near-empty gap. And look at the core. The core is much smaller. Estimates of its size vary a little depending on exactly how you define its edge, what brightness contour you draw your line at. But it sits somewhere between roughly 17,000 and 24,000 light-years across. Still large by any everyday standard, but compact next to that vast ring. A tight, rounded, almost featureless ball. And it is not blue. It is yellow. It is gold. It is the colour of old things. The stars in the core are cool and dim by stellar standards, older, redder, quieter. They have been around for a long time. They have used up their fury. A galaxy full of old stars like this is sometimes described by astronomers in a phrase I find quietly poignant as red and dead. The star formation has stopped. The gas that once made new stars has largely been used up or dispersed. What remains is an aging population of stars going about their slow, unhurried business, producing the warm golden light that you see at the centre of the ring. So here is the picture, set down plainly. On the outside, a wide, brilliant ring of young blue stars, very much alive, forming new suns right now. Or rather, 600 million years ago, which is the same thing from where we stand. On the inside, a compact, quiet, golden ball of old stars, long past their star-forming days, sitting still. And between them, a gap. Almost nothing. A broad, dark space where you would expect some kind of material, some kind of bridge or transition, but where there is instead, largely, emptiness, young ring. Old core, near empty gap. Those three things, together, are what makes Hoag's object demand an explanation. Any one of them alone would be unremarkable. Together, in this arrangement, they are a puzzle that has resisted a clean answer since 1950. But before we can even try to answer it, before we get to the competing origin stories and their particular failures, there's one thing we have to settle first. One foundational question that Hoag himself couldn't quite put to rest on his own with the tools of 1950. Is the ring genuinely part of this system? Or is it, as he feared, a trick, an optical illusion, a gravitational mirage? Because think about what a gravitational lens does. When a very massive object sits between us and a more distant light source, the mass bends the light from that distant source around itself. The light that would otherwise travel in a straight line gets curved by gravity, split, arced, and in perfect alignment, the distant source gets smeared into a complete circle around the foreground mass, a halo of bent light called an Einstein ring. Named for Einstein because general relativity predicted it, and because the universe, apparently, was paying attention. Einstein rings are real. We have found many of them. They are beautiful and slightly eerie, because what looks like a ring is actually a single background object whose light has been bent all the way around the foreground. If Hoag's object were one of these, then the ring would have nothing to do with the core. The core would be a galaxy in the foreground. The ring would be the image of a completely separate, much more distant galaxy, bent by gravity into a false circle. Poetic, but a false alarm. Hoag worried about this. And given the visual appearance of the object, a perfect-looking bright ring around a compact core, it was a completely rational thing to worry about. The geometry fits the illusion almost too well. So how do you test it? How do you decide whether the ring belongs to the core or whether it's just a very convincing trick of light and gravity? The answer is the redshift. Here is the thing about an Einstein ring. The foreground galaxy and the background galaxy are by definition at completely different distances. They only appear to be in the same place because one is lined up exactly behind the other. If you measure the redshift of the foreground core, the deflecting mass, it gives you one number. If you then manage to measure the redshift of the ring, the lensed background source, it gives you a completely different number, because the ring is genuinely much further away. The background galaxy has been traveling through more expanding space, and its light is shifted more toward the red. Foreground and background always have different redshifts. Always. That is what makes them foreground and background. But when astronomers measured the redshift of Hoag's object, both the core and the ring, separately, they got the same number. Or more precisely, they got the same number to a degree of precision that left no meaningful room for doubt. The core's redshift and the ring's redshift are essentially identical. They share the same recession velocity of roughly 12,740 kilometers per second. They are at the same distance. They are at the same place in the universe. That single measurement killed the lensing hypothesis. It closed that particular question with remarkable decisiveness. Because if the ring were a gravitational illusion, a distant galaxy bent into a circle around a nearer core, they would have different redshifts, significantly different. There is no version of the lensing story where core and ring sit at the same distance. It can't happen. Which means the ring is real. It genuinely belongs to the core. The two of them are physically associated, gravitationally bound, members of the same single structure. Hoag's doubt, his quiet, reasonable, professional suspicion that he might be looking at an illusion, was answered firmly and cleanly by the same technique astronomers use to map the expansion of the universe itself. The ring and the core are together. They always were. And that is what makes the object so strange, because the strangeness was never about whether it looked odd. It was always about the fact that the oddness is real. Arthur Hoag, it turns out, had really found something. And now there is a small thing I'd like to mention before we go any further, because you've been very kind to travel this far with me, and I think it's worth saying. After years of lying awake with a racing mind, deep sleep finally became possible for me. And when sleep finally came, real sleep, reliable sleep, learning came easier, energy returned, and the mind stayed sharper through the day. If you'd like to know the exact system that made that possible, there's a link in the pinned comments. It's worth a look whenever you're ready. Now, back to the ring. Once you understand that Hoag's object is a real, single, gravitationally bound system, core and ring belonging to each other, not a lensing trick, one number becomes even more arresting. The ring is 120,000 light-years across. That is not across the whole galaxy, including faint halos and diffuse gas. That is the ring alone. The star-forming, blue-glowing, 120,000 light-year ring. And if you stood somewhere at one edge of that ring and fired a beam of light toward the opposite edge, you would wait 120,000 years for it to arrive. Meanwhile, across that gap and into the core and across the core again is another 17 to 24,000 light-years. So the whole object, from one far edge of the ring straight through the middle and out the other side, spans somewhere in the neighborhood of 150 to 170,000 light-years. Bigger than the Milky Way in any direction you measure it. And yet it is not particularly famous. Most people, even people who spend a fair amount of time thinking about space, haven't heard of it. It sits in the sky in a modest constellation, 16th magnitude, far too faint to see, quietly resisting explanation while more photogenic or more dramatic objects get the attention. There is something almost shy about it. Now, one of the more arresting things about Hoag's object is not just how unusual it is in appearance, but how unusual it is statistically. Ring galaxies in general, galaxies with any kind of ring structure, are already uncommon. Most galaxies are spirals, ellipticals, or lenticulars. The elegant pinwheel spirals, the smooth, featureless ellipsoidal blobs, the lens-shaped lenticulars in between, these are the standard forms, the ones that fill galaxy catalogues and dominate the counts. Rings are a minority. But Hoag's object is not just a ring galaxy in the general sense, it belongs to a more specific and more exclusive category. Astronomers have named it the Hoag-type galaxy. And by that they mean something quite particular. Not just any ring, not the kind of ring you find in a barred spiral, the oval or circular ring that sometimes loops around the ends of the bar in a fairly ordinary galaxy. Not a faint halo of old stars swept around a disk. What they mean is the specific, striking, almost improbable geometry of Hoag's object itself, a detached, symmetric, nearly circular ring of actively star-forming material around a compact, bare, featureless core, with a significant gap between them containing very little luminous matter. That combination, detached ring, bare core, real gap, active star formation in the ring, is genuinely rare. Estimates of how rare vary somewhat depending on how strictly you apply the definition, but the figures commonly cited put Hoag-type objects at well under 0.1% of all galaxies. Fewer than 1 in 1,000, possibly considerably fewer depending on which features you require. General collisional ring galaxies, which we'll come to shortly, because they represent one of the competing explanations for how Hoag's object formed, are more common than the Hoag type, but still a small minority of galaxies overall. The Hoag type itself, with its cleanest geometry and most complete detachment, may number only a handful of confirmed examples in the known universe. Hoag's object is not just the most famous example of this class, it is the one that gave the class its name. It is the prototype, the reference, the thing that all the others are measured against. When astronomers find something that looks similar, they say it's a Hoag type and mean, specifically, something like this. Which means that Hoag, in 1950, didn't just discover one unusual galaxy. he accidentally catalogued a whole type of thing that hadn't been recognized as a type before, and which turns out to be one of the rarest galaxy morphologies in the observable universe. And yet, after more than 70 years, we still cannot say with confidence how one forms. That is not a rhetorical exaggeration for dramatic effect. It is literally the state of the astronomy. Hoag-type galaxies are so rare, and Hoag's object is so distant and so faint that the number of detailed observational studies of the object itself remains small. Each new pass of the Hubble Space Telescope, each spectroscopic study, adds something. But the dataset is thin compared to more accessible objects, and the origin question remains genuinely, honestly, open. This is a case where our most powerful telescope has pointed at an object multiple times, has given us more detail, has revealed more structure than Hoag could have imagined in 1950, and the better we can see it, the more complicated the picture becomes. More data, in this case, has not delivered a tidy answer. It has mostly made the puzzle richer. There is something that I find quietly beautiful about that, though I recognize that might be easy to say from a warm bed 600 million light-years away. What the improved data has done is sharpen the question. And to understand the question properly, to really feel why this object is so difficult to account for, you need to understand what options astronomers have when they look at something like this. What tools are in the explanation box? What is the physics allowed to do? Because the universe does make rings, just not usually like this. The ring is, in some sense, the interesting thing. The core, a compact, rounded, old star formation dead ball of stars, is not unusual by itself. Plenty of galaxies have old, compact cores. The gap, a region of relatively low luminous material between a core and an outer structure, also occurs in various forms across the galaxy zoo. But the combination of those elements, and especially the ring of actively star-forming material, sitting at that specific radial distance, with that specific detachment, with that specific symmetry, is the thing that needs explaining. Where did the ring come from? Why is it there and not closer in or spread more evenly? Why is star formation happening in it and not in the core? Why is the gap so clean? You'll want to have a sense of the whole galaxy environment to follow the answer. And before we step into the competing stories which are waiting for us, and which are the heart of why this object matters, let's sit for just a moment in the broader picture. Most of the galaxies we see around us have their own histories of interaction, merger, and disturbance. Galaxies are not islands in a smooth sea. They live in groups, in clusters, in filaments, great strands of matter stretching across tens and hundreds of millions of light-years, knotted at the intersections into dense clusters of hundreds or thousands of galaxies. They fall toward each other under gravity. They pass through each other. They strip material from each other's edges with tidal forces. They sometimes absorb smaller companions entirely. The night sky, if you could watch it on a timescale of billions of years, would look less like a calm display of fixed lights and more like a slow, vast, gravitational ballet, with partners trading places and occasionally merging all together. Against that backdrop, ring galaxies, in general, are usually understood as the aftermath of something dynamic. A disturbance of some kind, a perturbation that sent material moving outward in a ring, or that reorganized a galaxy's structure in a way that concentrated star formation into a circular shape. The physics that produces rings is not random. There are specific mechanisms, specific ways the universe knows how to do this, and they don't all look the same in the end. which is part of why working backward from the ring to the cause is so difficult. Hoag's object is the clearest and most extreme example of the type. And that clarity, the very thing that makes it beautiful, the thing that makes it look almost too geometrically perfect to be natural, is the same thing that makes it so difficult to explain. Because each of the mechanisms that could in principle produce a ring carries with it a set of predictions about what the result should look like. Predictions about symmetry, about debris, about the presence or absence of other structures, about what the gap should contain and how deep it should be. And Hoag's object doesn't fully agree with any of them. But we'll get to that. That fork in the road, the collision hypothesis and the instability hypothesis, and what each one predicts, and what Hoag's object actually shows, is the part of this story that I think most other accounts skim past too quickly. Most of what you'll read stops at nobody knows how it formed, and then shrugs, as if the mystery is a wall rather than a doorway. But it isn't a wall. There are two real, well-grounded explanations, each built on genuine physics, each supported by some evidence, and each undermined by a specific, concrete observation that doesn't quite fit. The mystery is not a shrug, it is an honest scientific fork, and it has been sitting at that fork for 70 years. That is where we're going next. And I think, wherever you are right now, maybe the lamp is still on, maybe the room has gone fully dark around you, I think you'll find that the fork is more interesting than the shrug. Because the shrug says we don't know. The fork says we know exactly what we don't know. And that is a completely different kind of thing. A ring of 120,000 light years. 600 million light years away. Seen as it was 600 million years ago, when the oldest animal with eyes was perhaps just learning to use them in warm Ediacaran water. Belonging to a class of galaxy so rare it makes up less than 0.1% of what the universe produces, carrying within it the signs of ongoing star birth in its blue outer ring, and the stillness of long-finished star birth in its golden core, bound together as one system, core and ring, not illusion, not lens, not trick, as confirmed by the same language of light that maps the expansion of everything. Arthur Hoag saw it in 1950. He doubted it. He was right to doubt it, and he was right that the doubt eventually had an answer. The lensing hypothesis died. The object stayed. And the question it left behind, the real question, the one about where that ring came from and what sequence of events could have arranged the universe into this shape, that question is still alive. Let's go follow it. So, here we are at the fork, and I want to stay here for a while, if that's all right with you. Not rush through. Because the fork is the thing, the two roads sitting in front of astronomy's best minds for 70 years, each one plausible enough to keep, each one broken enough that neither has won. And the way to actually understand Hoag's object, not just admire it, is to walk down each road and feel where the ground gives way beneath you. Let's do that slowly. No need to grasp every technical detail. Just follow the shape of the argument. The first road is the one most people think of when they hear the words ring galaxy. It is intuitive, it is dramatic, and it is the explanation that works beautifully for a different object. Picture, for a moment, the Cartwheel Galaxy. You may have seen images of it. If not, the name gives you most of what you need. It looks like a wheel, a great expanding ring of shocked gas and lit-up star formation rolling outward from a compressed inner hub, with faint spokes trailing back toward the center. It is electric blue at the rim, messy, asymmetric, full of the chaos you would expect from something in the middle of a transformation. And the reason it looks the way it does is, in astronomical terms, understood. About 200 million years ago, a smaller galaxy drove nearly straight through the center of what was then a normal disk galaxy. Not a glancing blow. Close to dead on. The intruder punched through the plane of the disk like a stone dropped into the surface of still water, and the ripple it sent outward was not made of water but of density, a compression wave that rolled through the disk's gas and stars, squeezing the gas as it passed, triggering new star formation all along the expanding front, lighting up a ring. And here is the key thing about the cartwheel. The intruder is still nearby, you can see it. In images of the Cartwheel Galaxy system, the culprit, the smaller galaxy that drove the collision, is right there, off to the side, identifiable, still feeling the gravitational consequences of what it did. There are tidal streamers and faint structural distortions that point back toward the event. The cartwheel is messy precisely because it is fresh. The collision was recent enough, cosmically speaking, that the evidence has not yet been tidied away by time. This is what a head-on collision leaves behind. A ring of star formation, yes, but also a scene. The broken crockery still on the floor. The perpetrator still in the room. Now, hold that picture in your mind and set it gently beside Hoag's object. The ring of blue stars. 120,000 light-years wide, the golden core sitting quietly at the center, the near-empty gap between them. And around the whole system, nothing, no small galaxy sitting nearby with the guilty look of something that recently drove through. No obvious tidal streamers reaching out into the surrounding space, no visible debris trail. No disturbed asymmetry of the sort that would linger for hundreds of millions of years after a violent encounter. Hoag's object is clean, almost unnervingly clean, and that cleanliness is both the thing that makes it beautiful and the thing that makes the collision hypothesis uncomfortable. Because if a smaller galaxy had driven through the center of Hoag's object, the way a stone drops through still water, that impactor had to go somewhere. Physics insists on it. The galaxy does not disappear after the collision. It might be dimmed, it might be disrupted, but its stars are still there. Its gravitational signature is still there. It would have continued moving away from the collision site, leaving at least some evidence of its path through the system. Some asymmetry in the ring, some faint streamer of material pulled out by the encounter. And yet, when astronomers have looked carefully at the region around Hoag's object, no obvious intruder candidate stands out. The object sits in relative isolation. The ring is too symmetric, too smooth at first glance to carry the clear fingerprint of a specific directional disturbance. Now, to be fair, and this is important, the absence of a visible intruder does not prove a collision never happened. It is possible that enough time has passed for the culprit to have wandered far from the scene, dimmed and disrupted beyond easy recognition. Collisional rings do fade. Impactors do travel. 600 million light-years away, with the faintness of Hoag's object to begin with. It is genuinely difficult to map the faint surroundings with certainty. The absence could be a limitation of what we have been able to observe, not proof that the collision did not occur. But that qualification cuts both ways. You cannot prove the collision happened either, if the evidence that would confirm it has wandered out of sight. This is the honest state of Hypothesis A. Plausible, supported by excellent physical reasoning, by the existence of the cartwheel as proof that this mechanism works in nature, and weakened specifically by the symmetry and cleanliness of the result and by the absence of a visible culprit. Wherever you are right now, If the lamp is still on, if the night is quiet around you, just let that sit for a moment. One road examined, and the ground gives a little. Let's try the other. Road 2 begins with a different premise entirely. It says no collision was required, no intruder, no stone dropped through a disk. Road 2 says that Hoag's object built its ring from the inside out, driven by instabilities within its own structure over a very long time. This is the proposal that Noah Brosch put forward in 1985. And to understand it, you need to know something about a type of galaxy that at first has nothing to do with rings at all. Barred spiral galaxies. You have almost certainly seen them. The Milky Way itself is one. They are galaxies with a long, bright bar of stars cutting through the center and spiral arms trailing off the ends of the bar rather than winding outward from the core. The bar is not a static decoration. It is a dynamically active structure, a density pattern that rotates, that funnels gas and stars along its length, that can redirect material across the galaxy in ways that smooth, unbarred spirals cannot. Bars can grow and, eventually, dissolve. A bar that forms, thrives for a few billion years, and then weakens and disappears is not an unusual endpoint in the life of a galaxy. The bar's influence lives on in the distribution of material even after the bar itself is gone. Now, one of the things a bar can do as it evolves and as its influence on surrounding material builds up over time is drive instabilities that push stars and gas into ring-like structures. This is not unusual in the barred spiral family. Many barred spirals have inner and outer rings, visible as arcs or partial ellipses of slightly enhanced star density or star formation around the ends of the bar, created by orbital resonances by the gravitational influence of the rotating bar pattern on nearby stars and gas. These are called resonance rings or secular rings because they build up over what astronomers call secular timescales, meaning very, very long ones. Not the sudden violence of a collision, measured in hundreds of millions of years at most, but the slow, patient reshaping of orbital families over billions of years. What Brosch proposed, looking at Hoag's object in 1985, was that what you are seeing is the aftermath of exactly this kind of slow internal process. At some point in its past, this object may have been a barred galaxy. The bar drove instabilities, it redirected material, and over a very long time it shaped the conditions that allowed a ring of gas and star formation to settle into roughly the position where we now see it. The bar has since dissolved. Bars can dissolve. The conditions that sustain them can fade, leaving behind, as its signature, the ring itself. And because the process was internal, symmetric, driven by the galaxy's own gravitational structure rather than a directional collision, the result is clean. No intruder, because there was no intruder. No debris, because no violent event deposited debris. Just the slow, invisible hand of orbital mechanics working over billions of years, arranging material into a near-perfect ring. It is an elegant idea, and it solves the cleanliness problem, which is the main thing that troubles the collision hypothesis. If you build the ring from inside, you do not need to explain where the perpetrator went, because there was no perpetrator. But the ground here also gives a little. The problem is the gap, that conspicuously empty space between the central core and the inner edge of the ring, tens of thousands of light-years of comparatively little luminous material, a gap wide enough to lose a significant galaxy in. Resonance rings in barred spirals do produce ring-like features, but the specific geometry of Hoag's object a wide, detached ring sitting at what seems to be a very large physical separation from a compact, nearly isolated core with a deep gap between them, is not the natural product of simple bar resonances in a disk. Resonance rings in barred spirals tend to sit at particular orbital resonance points close to the bar's influence, not floating far out in a near-empty moat around a bare core. The structure that Hoag's object presents is, by the standards of what the bar instability and secular evolution framework most naturally produces, unusually clean, unusually wide, and unusually detached. And then there is the question of evidence. If this galaxy was once barred, there should, in principle, be some trace of that bar. In the stellar kinematics, in the subtle distribution of older stars, in the dynamical signature of the remnant structure. Looking for a dissolved bar in a galaxy 600 million light-years away is genuinely difficult work. The object is faint, the angular scale is small, and extracting clean kinematic information from a system this distant pushes spectroscopy hard. The absence of a clear detected former bar does not prove there was no bar. But the presence of a bar, the one feature that would most directly support Brosch's 1985 proposal, has not been cleanly confirmed. Again, the road is plausible. The physics is real, and the ground gives a little. Now, there is a third name you should know, because they did some of the most careful work on Hoag's object, and they landed somewhere between the two roads, or perhaps on a narrower path running beside both. Schweizer, Ford, Jedrzejewski, Giovanelli, 4 astronomers working together, who in 1987 published a detailed study of Hoag's object. They were not simply choosing a side in the collision versus instability debate. They were doing the harder thing. They were trying to understand where the gas in the outer ring actually came from. Because this is the question underneath the question. Whatever mechanism assembled the ring, collision, instability, some combination of both. The ring requires gas. Blue O and B stars, the hot young stars that give the ring its colour, burn through their fuel in a few million years at most. A few million years is nothing in the life of a galaxy. If those stars are there now, or were there very recently, then gas was present in the ring recently. And that gas did not simply appear. It came from somewhere. It was either original to the system, redistributed by some internal process, or it was brought in from outside. Schweizer, Ford, Jedrzejewski, and Giovanelli favoured acquired gas. Their reading of the evidence pointed toward the ring's material having been gathered rather than simply rearranged, gas that was not originally part of the core galaxy's own inventory, but was accreted from the surrounding environment. They acknowledged, with the careful honesty that good science requires, that the exact origin story remained open. But the direction their work pointed was toward accretion and interaction as the better explanation for where the ring's fuel came from, even if the precise form of that interaction, a direct head-on collision. A more glancing encounter, a slow drawing in of cold gas from a cosmic filament, was not cleanly resolved. This is worth sitting with. 4 careful astronomers, a year after Brosch, looking at the same object and landing on a different interpretation without being able to settle the matter. Not because they were less careful, because the object resists settlement. That is the honest character of Hoag's object. It is not a mystery in the sense of something that looks mysterious but will obviously turn out to have a mundane explanation once someone clever enough turns their telescope to it. It is a mystery in the harder sense, the sense where our best physical frameworks make competing predictions, where our best observations have not yet been sufficient to choose cleanly between them, and where even improving the observations, as we will see, has not yet brought a verdict closer. Now, let me say something about the same redshift fact one more time, because it matters here in a specific way that is easy to miss. One of the ways the brain, very naturally, tries to simplify Hoag's object is to wonder whether it might be two separate things that happen to be lined up along our line of sight. The core in the foreground, the ring in the background, or some other arrangement that turns a single strange object into two ordinary objects accidentally superimposed. It is a reasonable instinct. Astronomers apply it routinely because coincidences of alignment do happen, and two ordinary things is always a simpler hypothesis than one extraordinary thing. And we know this instinct is right to apply here, because there is, in fact, a separate galaxy aligned with Hoag's object. The second ring galaxy, visible through the gap that we mentioned earlier. That one is a genuine chance alignment. It sits at a higher redshift, a greater distance, completely unrelated to Hoag's object, just happening to sit along the same line of sight from Earth. So the separate things instinct is not wrong in principle. But for the core and the ring of Hoag's object itself, this shortcut has been ruled out. Core and ring share essentially the same redshift. They are moving away from us at the same speed, the recession velocity near 12,740 kilometers per second, because they are in the same place in the expanding universe. The light from both carries the same cosmological stretch, the same shift toward the red end of the spectrum, the same distance signature. They are not two separate objects that happen to overlap on our sky. They are one gravitationally bound system, the core and the ring orbit within the same dynamical structure. Whatever created the ring also had to interact with or emerge from within the same system that contains the core. The two-galaxy shortcut, maybe it's just an illusion, maybe it's just two things lined up, does not work here. The physics of light closes that door. And this is actually important because it narrows the problem in a specific way. Any valid origin story for Hoag's object has to explain how a single gravitationally bound system ended up with young star-forming gas, sitting in a wide ring at large radii, while the center holds a quiescent population of old stars, with a significant gap between the two. Both components belong to the same object. That is the puzzle the physics must solve. The collision hypothesis tries to solve it through a violent event, an impactor that sent a density wave rolling outward through an ancient disk, sweeping gas into the ring while the disrupted core settled into quiescence. The secular evolution hypothesis tries to solve it through slow internal restructuring, a bar that gradually channeled material outward over billions of years before dissolving, leaving the ring behind. Schweizer, Ford, Jedrzejewski and Giovanelli tried to solve it through acquired gas, material gathered from the environment by some interaction, seeded into the ring from outside the original galaxy's own budget. All three are working within the same constraint, same system, one object, core and ring together. The same redshift fact is not just a piece of evidence, it is the frame that holds the problem in its proper shape. And the problem in its proper shape is still open. There is something I find genuinely moving about that, though I want to be careful not to overdress it. I do not mean it in the way that popular framings sometimes reach for awe by exaggerating how baffling the universe is, as though the right response to difficult science is to throw up your hands and call it all magic. The truth is quieter than that. The truth is that Hoag's object is a specific, bounded problem. We know roughly how big it is. We know roughly how far away it is. We have named the two main hypotheses. We have identified the specific observations that each hypothesis needs and the specific observations that each one struggles to explain. We have a named astronomer who proposed the bar instability idea, another group who argued for acquired gas, a study from 1987 that pushed the conversation forward without closing it. The problem is not vague, the problem is precise, and the fact that a precise problem, held by skilled people for more than 70 years, has not yet been resolved, that is the honest, specific shape of what we mean when we say this object resists explanation. Not magic. Not a shrug. A fork in the road, both roads examined, both roads still open. Wherever you are right now, if you are still with me, and it is perfectly fine if you are only half with me, if the room has grown softer and the words are drifting a little, just let that be the thing you carry into whatever comes next. The universe built a structure that looks geometric, that looks almost designed. A ring of young stars the width of a whole galaxy, floating around a quiet golden core with a gap between them so clean you could park a second galaxy in it, which, by chance, a second ring galaxy nearly fills, though from a completely different distance, a completely separate strand of the universe's fabric. And the structure is real. It is a single-bound system. It is not an illusion, not a lens trick, not two things masquerading as one. It is genuinely there, genuinely that shape, genuinely that old, and genuinely unexplained in the specific, technical, honest sense. Two good hypotheses, each with evidence behind it, each with a flaw the evidence cannot yet bridge. Arthur Hoag looked at it in 1950. He doubted it. He was right to doubt, and he was right that the doubt had an answer, or rather that the doubt had a partial answer. Yes, it is real. No, it is not a lens. And then the next question, the one he perhaps could not have fully predicted, would outlast him by so many decades. Where did that ring come from? What sequence of events, in what order, over what span of time, arranged the universe into this shape? That question is still in the room. Let's stay with it a little longer, because there is more to say. Not about the hypotheses themselves, but about what happened when astronomers turned better instruments toward Hoag's object and discovered that the ring, examined closely, is not quite the perfect geometric shape it first appears to be, and about what that complication means for both explanations, and about why this object sits so awkwardly in the standard way we classify galaxies, refusing to fit neatly into the system we built to describe almost everything else we see, and about the background ring galaxy, the one glimpsed through the gap, and what it actually is and is not, because it is one of the stranger coincidences in the whole catalogue of astronomical images. And it deserves a proper accounting, not just a passing mention. And about why, when you look at an object this far away, you are not seeing the present. You are seeing the past. 600 million years of past. And what that means for the question of what Hoag's object looks like right now. A question that has a specific, rather humbling answer. We'll come to all of it. Gently, one thing at a time. But first, just rest here for a moment, at the fork in the road. Hypothesis A, with its beautiful physical intuition and its missing perpetrator. Hypothesis B, with its elegant internal logic and its struggle to build something so clean and so wide. The 1987 work of Schweizer, Ford, Jedrzejewski and Giovanelli pushing toward acquired gas without quite reaching the finish line. and the same redshift fact holding everything in frame, insisting that core and ring are one thing, one system, one problem to explain. The night is quiet around you, wherever you are, if it is late and the world has gone still. Let the image of it drift behind your eyes for a moment, if you like. A ring of blue stars, 120,000 light-years wide. An old golden core, a gap so clean it looks planned, 600 million light-years away, real and unexplained, and still, after all this time, sitting at the fork. So, let us take the fork apart. Hypothesis A first. The collision model, and it is, genuinely, a beautiful piece of physical reasoning, which is part of what makes its difficulties so frustrating to sit with. The idea goes something like this. Long ago, and we are talking about an event that may have occurred billions of years before the light now reaching us even left the object, a smaller companion galaxy fell in. Not a glancing blow. Not a near miss. A nearly head-on plunge through or very near the centre of what was then a disk of gas and stars. A bullet through a target, more or less. And what happens when you do that, when a dense intruder drives through the middle of a galactic disk, is that the disturbance does not stay at the point of impact. It propagates, like a stone dropped into still water. A ripple spreads outward through the disk, a density wave, compressing gas as it goes, and compressed gas in galaxies does one thing reliably. It collapses, it forms stars, hot, luminous blue stars, exactly the kind you see in the ring of Hoag's object right now. This mechanism is not speculation. It is well understood. We have seen it work. The canonical example the object astronomers point to when they want to show this process happening in the real universe is the Cartwheel Galaxy. You may have seen images of it, a great ringed structure in the constellation Sculptor, hundreds of millions of light-years away, with a bright, clumpy ring and a disturbed centre and, crucially, the culprit still nearby. The intruder that passed through the cartwheel is still visible. A smaller galaxy, identifiable, positioned nearby, the debris of the interaction still stretched between them, like pulled taffy. The geometry of the collision is recoverable. Astronomers can run the encounter backward in a simulation and watch it happen, the plunge, the ripple, the ring igniting with star formation. It works. The physics is coherent. And that is precisely the problem with applying the same logic to Hoag's object. Because the intruder is not there. There is no obvious culprit sitting nearby. No small companion caught in the act. No trail of tidal debris stretched between the ring and some fleeing companion. The cartwheel gives you the crime scene and the suspect. Hoag's object gives you the crime scene, the aftermath, and nothing else. The perpetrator has vanished entirely or was never there. You might say, perhaps enough time has passed, that the intruder has long since merged with the core, been absorbed, become invisible inside the central stellar population. That is possible. It is not impossible. But there is another difficulty that runs alongside the missing intruder, and it is the symmetry. Collisional ring galaxies are not, as a rule, perfectly symmetric. They are often lopsided, clumpy, disturbed in ways that reflect the messiness of the original impact. The cartwheel is not a smooth, even ring. Real impacts are not clean. They leave asymmetric signatures, tidal distortions, off-center bulges. Hoag's object, at first glance, looks almost geometrically ideal. A ring so even it seems drawn with a compass. A core so round it could be a ball of light. This near perfection is at least partly explained by viewing angle. We see it nearly face-on, and a slight tilt would reveal an ellipse, rather than a circle, but even accounting for that, the object is unusually clean for something that is supposed to be the aftermath of a violent encounter. The collision hypothesis does not produce something this tidy without considerable effort and special pleading about the geometry of the original impact. So we move to hypothesis B. The internal story. The secular evolution model, here the thinking is different. No collision required. No intruder. Instead, the proposition is that this was once a barred galaxy. A galaxy with a bar of stars and gas running through its center, a structure that is, in fact, extremely common in the universe. The Milky Way itself has one. Bars are dynamic things. They are not permanent. Over long timescales, through a process that involves gravitational resonances and the slow redistribution of angular momentum, a bar can weaken and dissolve. And as it does, it can funnel material outward, building a ring at the edge of the bar's influence, a ring that gradually becomes detached as the bar fades away. Meanwhile, the galaxy accretes cold gas from the surrounding cosmic web, gas falling in along dark matter filaments, feeding the ring, triggering the star formation that produces the young blue population you see today. Noah Brosch proposed something along these lines in 1985. The bar is gone. Its absence is why there is no obvious internal structure between the core and the ring. The ring is the legacy of a process that has already largely completed, a structure the galaxy built for itself over billions of years without needing an external impact at all. This is an elegant hypothesis. It explains the symmetry naturally, an internal process, playing out in a disk that was already rotationally symmetric, would tend to produce symmetric results. It explains the absence of a visible intruder. It fits with the general observation that rings do form around barred galaxies through secular processes, and that cold gas accretion is a real and understood mechanism in galaxy evolution. But it struggles with the specifics. The ring of Hoag's object is wide, and it is detached. There is a genuine, conspicuous gap between the ring and the core, a gap that is large and relatively empty of bright material. Getting a bar instability to produce something that clean, that wide, that isolated from the core is not straightforward. The internal secular models for ring formation tend to produce rings that are somewhat closer in, somewhat more connected to the central structure. Making the geometry of Hoag's object work with this mechanism requires careful tuning of conditions that are hard to constrain observationally at this distance. The two hypotheses sit on opposite ends of a spectrum. One says something fell in. One says it grew from within. Both are grounded in real, understood physics. Both apply that physics to this specific object and find the fit imperfect. In 1987, Schweizer, Ford, Jedrzejewski and Giovanelli, four astronomers working with spectroscopic observations of the object, published a study that leaned toward a third framing, or perhaps a refinement of the first. They argued for an accretion or interaction origin, but framed around the acquisition of gas rather than a straightforward intruder bullet scenario. The ring's gas in this picture was acquired, gathered from outside, from a companion, from a filament, from some kind of interaction, rather than being original to the system or produced by an internal instability. The core settled into its old quiescent state, while the newly acquired gas collected in a ring and began forming stars. Schweizer and his collaborators were careful, as careful astronomers tend to be when the evidence is genuinely ambiguous, to acknowledge that the full history of the object remained open. Their work is a foundational reference. It moved the conversation forward without closing it. What all of this has in common, all three framings, is that they respect one boundary condition that the observations make absolutely clear. The core and the ring share the same redshift, not approximately, not within a large margin of uncertainty, essentially the same redshift, which means they are at the same distance, which means they are a single gravitationally bound system. One object, one problem to explain, not two. This matters because it might otherwise seem tempting, faced with an object this strange, to reach for a simpler story. Perhaps the ring is one galaxy and the core is another, superimposed by chance along our line of sight, the way the background ring galaxy, the one visible through the gap, is genuinely a different, more distant object. Perhaps what looks like one system is really two unrelated things in accidental alignment. The redshift rules that out for the main object. Core and ring move together through the universe at essentially the same velocity. They are bound to each other. They share the same cosmic address. Whatever formed the ring, it is part of the same system as the core, connected to it gravitationally. A product of the same history. The shortcut is closed. And so we arrive at the question that has quietly been waiting underneath all of the others. Why does it look like that? Because it does look like something. Not just unusual, not just rare, it looks almost designed. A ring of young blue stars, traced in a near-perfect arc around a golden core of old ones, with a gap so clean and wide between them that you could lose entire galaxies in it. And we have talked about how the ring formed, or rather, we have talked about the two best guesses astronomers have for how the ring formed, and the problems that make each guess uncomfortable. But we have not yet talked about the thing you would notice first, before any of the physics, before any of the history. We have not yet talked about the simple fact that it looks almost geometrically perfect, and that is worth slowing down for, because the appearance and the reality are, as is so often the case in astronomy, slightly different things. Here is something to consider while you settle in. Wherever you are right now, however you are lying, think about a coin. A flat, round disc. If you hold it up in front of you, face on, it looks like a circle. A clean, elegant circle. But tilt it slightly, even a few degrees, and it becomes an ellipse. Tilt it more, and it becomes a thin oval. Tilt it far enough, and it disappears almost entirely into a line. The same object, the same geometry, but what you see depends entirely on the angle from which you are looking. Hoag's object is something like that coin. We happen to view it nearly face-on. Our line of sight, across approximately 600 million light-years of space, arrives at Hoag's object from a direction that is almost perpendicular to the plane of the ring, which means we see the ring spread out in front of us like a halo, like something drawn with a very steady hand, like a structure that seems almost too orderly for a universe that is, in general, not particularly concerned with tidiness. And in that face on orientation, the near-empty gap between the core and the ring is as visible as it could possibly be, and the arc of the ring closes almost perfectly on itself, and the whole arrangement looks from 600 million light-years away, like something someone placed there deliberately. But if we were watching from a different position in space, from a direction that caught the ring at an angle, this same object would not look like a ring at all. It would look like a stretched ellipse around a compact core, an elongated structure, strange perhaps, but not nearly so arresting, not nearly so perfectly circular, not nearly the object that caught Arthur Hoag's eye in 1950 and has been catching eyes ever since. The face on view is, in that sense, a kind of gift of geometry. We are positioned by pure accident of our location in the universe at the angle where the structure shows its most dramatic face. A few degrees of tilt, and it would still be a remarkable object, but it might not be famous. This is not to diminish it. The ring is real. The gap is real. The color contrast between the young blue outer stars and the old golden core is real, and it is not an artifact of viewing angle, but the impression of near-perfect circular symmetry, that quality that makes people stop and stare at the image and wonder whether something so regular could truly be natural. That impression is partly a product of where we happen to be standing in the cosmos. Partly, not entirely, but partly. And there is another complication, a gentler one, but real. When we talk about Hoag's object looking perfect, we are usually talking about a particular image, the famous one. The Hubble Space Telescope image from 2001, produced by the Hubble Heritage Team based on WFPC2 data. The one that circulates endlessly and appears on screensavers and magazine covers, and the kinds of articles that begin with phrases like mind-blowing or unexplained. That image is beautiful. It is also, like all images, a product of choices about what to show and how to show it. Later work, with higher resolution and deeper exposures and careful spectroscopic study, began to fill in details that the first impression had smoothed over. Ido Finkelman, working with Noah Brosch and collaborators, conducted detailed studies of Hoag's object that revealed something the original image had not made obvious. The ring is not uniformly bright. It is not a continuous, unbroken river of evenly distributed starlight. It has clumps. It has knots, brighter patches where star formation is concentrated, slightly denser regions separated by slightly dimmer ones. When you look at the ring carefully, the way a careful astronomer looks at it rather than the way a dazzled observer does, it starts to look less like a perfectly drawn circle and more like a chain of star-forming regions loosely strung around a common orbit. Bright beads on a thread with gaps and variations between them. And that is not a failure of the object, that is just the reality of it. Star formation does not happen uniformly. Gas does not distribute itself in a perfect ring of constant density. What we see in the ring is the universe doing what it actually does, which is to produce structures that have an overall shape but that are, on inspection, messier and more complicated and more interesting than the summary suggests. The clumps and knots and asymmetries that Finkelman and Brosch's work brought into focus are not blemishes on the image. They are data. They are the universe telling you something more detailed than the pretty picture told you. Brosch had been thinking about Hoag's object for a long time. His 1985 work on the bar instability hypothesis, which proposed that the ring might be the legacy of a dissolved central bar that had redistributed mass outward over billions of years, was already a careful, patient engagement with an object that resists quick answers. And the later observations only deepened the engagement. The clumpiness was one piece of it. There were hints of additional faint structure, inner features, subtle asymmetries in the core, things that suggest the object's history is more layered and complex than either of the two simple origin stories would imply. The ring does not look obviously like the aftermath of a single clean event. It looks like something that developed over time, in complicated ways, in a universe where processes overlap and interact and leave traces that are hard to read cleanly. What this means for the question of origin is that better data, in the case of Hoag's object, has not made the answer clearer. It has made it more complicated. Each new observation that reveals more detail is also an observation that a clean explanation must account for. The knots and the clumps and the asymmetries are all constraints. Any model that explains the ring must also explain why the ring has the particular irregular texture it has, and that is a harder problem than explaining why there is a ring at all. Better instruments have, in this case, done what instruments sometimes do, which is to replace a simple mystery with a more demanding one. This happens more often than people expect. Science is, in that way, a process of accumulating richer questions as much as a process of finding answers. There is also the matter of where Hoag's object sits in the larger framework that astronomers use to organize their thinking about galaxies. If you have spent time looking at astronomy, you may have encountered something called the Hubble tuning fork. It is a diagram, simple but elegant, that Edwin Hubble proposed in 1926 that arranges galaxies by their visual morphology, their shape. On the left side of the tuning fork are the elliptical galaxies, round or slightly elongated balls of stars, ranging from nearly spherical to noticeably elongated. The tuning fork then splits into two prongs. One prong carries ordinary spiral galaxies with flat disks and winding arms. The other prong carries barred spiral galaxies, where the arms emerge from the ends of a straight bar rather than directly from the core. And at the junction of the handle and the prongs sit the lenticular galaxies, which have disks like spirals but no prominent arm structure, something in between the two. This classification scheme is not perfect, and modern astronomers use more sophisticated tools, but it remains a useful shorthand, a quick way of locating a galaxy in the space of possible shapes and structures. Where does Hoag's object go? It does not go comfortably anywhere, a detached ring of young blue stars floating in space around a compact, nearly spherical core of old ones, with almost nothing in between, does not fit neatly into any slot on the tuning fork. The core might look a little like a lenticular galaxy, a smooth, relatively featureless stellar mass. But lenticular galaxies do not typically come wrapped in a wide, nearly empty gap, and then a ring of actively star-forming material tens of thousands of light-years further out. The ring itself looks nothing like a spiral arm which curves and is attached and is part of a continuous disk structure. The gap is the thing that makes Hoag's object impossible to classify conventionally. The gap is too wide. The separation between the core and the ring is too clean. Whatever the Hubble sequence was designed to capture, it was not designed with this in mind. There is a real sense in which Hoag's object is not just an astronomical mystery, but a taxonomic one. It is an object that the existing categories do not quite contain. Astronomers have ways of handling this. The object is often noted as peculiar, which in the technical vocabulary means roughly what it sounds like. It has properties that mark it as unusual, that set it apart from the standard morphological classes, that require some additional qualifier beyond the usual labels. Hoag-type galaxy is itself the qualifier, a category built around a single prototype, a category that says, in effect, this kind of thing exists, and we are naming it after the man who found the first one, and we cannot yet fully explain what makes it what it is. Hoag-type galaxies as a class are a handful, not many dozens, not even many tens. The number of objects that show the specific Hoag geometry, a near-perfect, detached, symmetric ring around a compact core with almost nothing in the gap, can be counted in a very small number of clean examples. Ring galaxies in general, collisional rings and resonance rings, and the various structures that get loosely called ring-like, are themselves a small minority of the galaxy population. General ring structures might appear in a few % of galaxies, depending on how broadly you draw the line. But true Hoag-type objects. The ones where the ring is wide and symmetric and detached, and the gap is genuinely nearly empty, and the core is a smooth, compact old stellar mass, those are rarer still, well under a fraction of a percent of all galaxies. The universe makes these rarely and apparently not reliably, and the fact that one of the clearest examples happens to be close enough for us to study in detail, and happens to be oriented face-on, and happens to have been found by someone paying careful attention in 1950, is, like many things in astronomy, partly a matter of fortune. Which brings us to the gap itself. Because there is something else in the gap, and it deserves its own moment, because it is one of the strangest little coincidences in the visual astronomy of the last half-century. If you look at the 2001 Hubble image, you will notice, in the gap between the core and the ring, at approximately the 1 o'clock position, a faint and distant smudge that is itself shaped a little like a ring. It is small, it is far away, it is easy to miss if you are not looking for it, but it is there. Another ring-like structure, visible through the gap of Hoag's object. As if the universe had arranged, just for this one line of sight, a ring framed within a ring. A matryoshka of galaxies nested by chance into one another. This background object is not physically associated with Hoag's object. It is not nearby. It is not part of the same system. It is simply another galaxy, much further away, at a much higher redshift. Sitting on the far side of an enormous volume of space, behind Hoag's object from our perspective, and because the gap in Hoag's ring happens to be wide and relatively clear of bright material, we can see through it to the more distant universe beyond. And that more distant universe happens to contain, in precisely that direction, this other ring-like structure. The alignment is geometrical luck, nothing more. Two unrelated objects, separated by an immense distance, appearing to nest inside each other because of where we are looking from. It is, in its way, beautiful. It is also a reminder of how much of what we see in the sky is a product of our specific vantage point. The universe is vast and filled with structures, and our line of sight passes through all of them at once, and what we see is the superposition of everything along that line, at every distance, collapsed into a single image. Most of the time we can sort it out. The redshifts tell us what is far and what is near. The spectroscopy distinguishes the background from the foreground, but visually, at first glance, it can look like a coincidence so extraordinary that it must mean something. It looks like the universe is arranging itself for us. It looks like something placed there to be found. That feeling, the feeling that this is arranged, that this is too neat, too circular, too symmetrical to be natural, is worth pausing on for a moment. Because it comes up frequently with Hoag's object, and it comes up in a specific form. There is a version of the story of Hoag's object that circulates in certain corners of the internet, and occasionally in breathless popular articles that interprets the geometric quality of the ring as evidence of something deliberate, a structure built rather than grown, an artifact rather than an evolved object, something that points, in this framing, toward an intelligence of some kind that operates at scales we can barely comprehend. The phrasing varies. Sometimes it is described as a cosmic eye, sometimes as a ring of fire, sometimes as something that a sufficiently advanced civilization might have constructed around a central star system as a kind of megastructure. This is a myth, a gentle, understandable myth, because the human tendency to see intention in patterns is ancient and deep, and Hoag's object is genuinely striking. But it is a myth. There is no evidence for artificial construction in anything about this object. The physics of how ring galaxies form, even incompletely understood as it is sufficient to produce structures like this without invoking any intelligence. Gravity, gas, stars, time, and the dynamics of disk galaxies operating over billions of years can make rings. We see rings around other galaxies. We see the Cartwheel Galaxy, formed by a collision with its expanding ring of star formation. We see barred spiral galaxies with inner and outer resonance rings. We see the remnants of galaxy interactions scattered across the observable universe. Ring structures are unusual, but they are natural. They are things galaxies do, or things that happen to galaxies under the right conditions. The conditions for Hoag's object remain debated, but the category of natural explanation is not in doubt. The perfection is partly viewing angle. The perfection is partly the resolution and framing of a single famous image. The perfection, when you look closer, as Finkelman and Brosch looked closer, turns out to have texture and clumpiness and asymmetry underneath it. The universe built something remarkable here. It did not build something impossible or supernatural. It built something that our best physics still cannot fully trace back to a single clean origin, and that, if you think about it, is more interesting than a myth. An object that is genuinely natural and genuinely unexplained is a richer thing than an object that is manufactured and therefore requires an inventor. The unexplained is the point. And it has been the point for a long time now. Arthur Hoag found this object in 1950. He wrote it up carefully and honestly, noting his initial suspicion that it might be a gravitational lens, noting that the ring and the core shared the same redshift and were therefore physically associated, noting that he was not sure what it was. That was the beginning of the conversation. It is now more than 70 years later, and the conversation is still open. Schweizer and Ford and Jedrzejewski and Giovanelli, who studied it carefully in 1987, moved the conversation forward without closing it. Brosch, who returned to it repeatedly, brought new frameworks and new observations without settling it. Finkelman and collaborators, who brought the higher resolution Hubble data to bear on the ring's fine structure, added detail and constraint without resolving the fundamental question. The Hubble Space Telescope, which is arguably the most powerful tool we have ever aimed at the sky in terms of optical resolution, produced the most famous image of Hoag's object in 2001 and revealed the background ring in the gap and gave us more to think about. And the origin is still debated. This is not a failure of astronomy, it is worth saying that clearly. Astronomy is not failing when it confronts Hoag's object and admits uncertainty. Science as a process involves a large number of genuinely open questions at any given moment. Questions that are not answered yet, not because the people working on them are not skilled or not trying, but because the evidence is genuinely ambiguous, and the object is genuinely difficult and faint and distant, and there are only so many hours on the large telescopes and so many people whose specific expertise and curiosity draws them toward this particular problem. Hoag's object is famous among the general public, but it is, relative to its fame, somewhat understudied in the technical literature. It is not a top priority for the majority of observational campaigns. It sits at 600 million light-years, too faint and too distant for easy detailed spectroscopy, too singular to anchor a large statistical study. It is the kind of object that gets visited, studied carefully by a dedicated few, and then waits. In the meantime, the universe keeps its secret. The ring keeps forming stars, somewhere out there, across a gap we cannot cross. in a light that has been travelling toward us for 600 million years and has not yet told us everything it knows. The knots of blue light in the ring, the clumps of new star formation, are happening now in the sense that the physics is ongoing. But the now we are talking about is a now that already existed 600 million years ago, when the Earth was in the Ediacaran period, when the first complex multicellular life was beginning to appear in the fossil record, when there were no eyes anywhere on this planet capable of wondering about anything, when the light from Hoag's object was beginning its long journey across the expanding universe toward a tiny planet that had not yet invented curiosity. That light is here now. We have caught it. We have turned instruments on it and measured its redshift and its spectral lines and the colours of its stars and the texture of its ring. And we still cannot fully explain how it got to look the way it looks. There is a certain quality to that, a certain flavour. It is the flavour of a mystery that is not a mystery in the dramatic, thriller novel sense. There is no villain here, no hidden answer that someone is suppressing, no ancient secret waiting for the right investigator. The answer is simply out there, in the data that has not yet been collected, in the models that have not yet been refined, in the instrument time that has not yet been allocated, in the graduate student or the postdoctoral researcher or the seasoned astronomer who has not yet turned their full attention to this particular corner of Serpens Caput and decided to sit with it long enough to crack it open. The answer exists. We do not have it. And that is, in its own way, one of the most honest things I can tell you about the universe. It is full of objects that we have found and named and measured and cannot yet explain. Hoag's object is not unique in being mysterious. It is unique in being this mysterious for this long, in a form this visually striking, with this much attention paid to it, and still no resolution. It is the clean version of a very common scientific experience, which is the experience of knowing that something happened and not yet knowing how. We know the ring is there, we know it is forming stars, we know the core is old and quiet, we know the gap is nearly empty, we know the whole system is gravitationally bound and moving together through the universe at the same velocity. We know the ring is about 120,000 light-years across, slightly wider than the Milky Way's disk, meaning that you could, in principle, place our entire galaxy inside the ring and have room to spare. We know that we are seeing all of this as it was 600 million years ago, a snapshot frozen by the finite speed of light, and that whatever Hoag's object looks like at this moment in cosmic time, we will not know for another 600 million years. We know all of these things, and we do not know how it came to be what it is. That feels to me less like a problem and more like a kind of companionship. Out there in Serpens Caput, 120,000 light-years of young blue stars are circling an old golden core in a system we found by accident and cannot yet fully read. And the mystery is not threatening. The mystery is just the universe being larger than our current understanding, which it has always been, which it has always managed to remain, no matter how much we learn. No matter how many instruments we build or how many hours we spend with our attention turned toward the dark. There is something in that worth carrying with you. We are made of stars. The ordinary biological fact of it, the carbon and the oxygen and the iron in your blood, all of it forged in stellar cores and scattered by stellar deaths long before this solar system formed. The atoms in your body have been part of this universe for billions of years, part of the same universe that contains Hoag's object, part of the same expanding volume of space and time and physics. The light from those blue ring stars and your own quiet awareness of it right now. The small lamp still on. The pillow, the weight of the blanket, the steady rhythm of your breathing. All of this is the universe happening to itself in different forms, the same physics wearing different clothes. Matter organized in different ways at wildly different scales. A ring 120,000 light-years wide around a golden core of ancient stars, 600 million light-years away, and you, wherever you are, in whatever quiet corner of this improbable planet you have settled into tonight. Both of you, in some sense, part of the same story. Both of you made of the universe's own material, arranged by the same gravity and electromagnetism and thermodynamics that arranged Hoag's object, operating at different scales, but not different in kind. The ring and you are not opposites, you are different versions of the same underlying reality, and the mystery of how the ring formed. The question that has been open since 1950 and is still open tonight is also, in a way, a version of the mystery of why anything is arranged the way it is. Why this particular configuration and not another? Why these stars in this ring at this moment in cosmic time? Why this particular arrangement of atoms in this particular room, aware of something 120,000 light-years wide? 600 million light-years away, that is too far to visit, and too strange to fully explain, and too beautiful to look away from. Arthur Hoag looked through a telescope in 1950 and saw something he had not expected. He was not sure, at first, whether it was real or an optical trick, whether the ring was a physical structure or a mirage. He looked more carefully. He measured. He published honestly. He did not pretend to know what it was. He said, in the careful language of astronomy, that this is a remarkable and puzzling object, and that further study would be needed. And then he moved on to other things, the way astronomers do, the way everyone who encounters something genuinely strange eventually has to. Because life moves forward, and there is always more to look at, and the universe does not wait for any of us to finish understanding it. But the object stayed. The object is still there. And the question is still open. And tonight, somewhere, there is probably an astronomer who has looked at the Hubble image and felt something catch in their attention, some small snag of curiosity, and who has started reading the papers, the Schweizer 1987 study and the Brosch 1985 analysis, and the Finkelman work on the ring's fine structure, and who is beginning to form a hypothesis, a new angle, a new observational strategy, something that might, in a few years or a decade or more, bring the picture into sharper focus. That work is happening. It is slow and careful and mostly invisible, and it is how science actually works. Not in sudden revelations, but in patient accumulation, one careful measurement at a time. And in the meantime, the light keeps coming. 600 million light-years of it arriving at our telescopes and our eyes, carrying the information of a structure we cannot yet fully read. In a universe that has never promised us easy answers, only beautiful questions and the capacity to ask them. Which is honestly quite a lot to carry into sleep. If you are still with me, I am glad you are here. If you drifted off somewhere in the middle of all of this, that is equally fine. The ring will still be there when you wake up. Serpens Caput will still be there, rising and setting above you, carrying its improbable resident across the sky. The questions will still be open. The gap between the core and the ring will still be nearly empty and not quite explained. Everything I have told you tonight will still be true in the morning. If you enjoyed this slow drift through one of the universe's more puzzling corners, A like and a subscribe does genuinely help this small channel keep going. Small channels like this one depend on that kind of support more than you might think. And if you want to leave a note in the comments, I would love to know where you are listening from tonight and what time it is in your part of the world. That small thread of connection, from wherever you are to here, always means something. Rest well. The universe is enormously large and mostly dark, and it contains, in a constellation called the Serpent, a ring of young blue stars 120,000 light-years wide that no one has fully explained in 75 years of trying. And that is, by any measure, a good thought to fall asleep to. A quiet awe, a mystery that is not a threat but a companion. Something out there in the dark that is stranger and larger and more patient than any answer we currently have for it. Close the books, dim the lamp. Class is over, sleepy scholar.